So we're back to our customer Mr. Immaculate who sent 3 sets in, and they all look immaculate apart from the Realistic 1001 handheld, which has not got an immaculate aerial. So the first set I've pulled out of his box is the Realistic 1004, which is the most expensive emergency set which was on the market. I think most of the time it sold for $99.99, but I'm sure there was a time it went for $139.99 or even $149.99. There was a poor rate of exchange that year, and it was very expensive. And of course that normally comes in a kit, and he's probably got the full kit with the mag mount and a cigarette lighter and so on. What I'm going to do, I'm not going to do all this on the video. We've got one of our own here, and this is something which is supposed to live in my hallway in case we have to go out and use an emergency CB set because we're going in a car with no CB. Don't know why we've got 2 fag lighter adapters in there, but we have. And what we also have is the correct mag mount. So what we're going to do is I'm going to borrow our lead, and then it'll save me the bother of faffing about. I've even still got the spare fuse in our kit. So we'll power his off that, and just looking at serial numbers. Oh, they don't even have serial numbers. How tight's that? So I don't know which way these are supposed to go around. It must be that way. What shouldn't be there is that. That's what the problem is. So when we come to doing an on-the-air test, we're doing an on-the-air test in the usual way, where I have it on the base and use it as base station and the aerial here, and then we'll borrow my mag mount and we'll test the customer's set on a field test. So we're going to do the repair, we're going to do an on-the-air test, we're going to do a field test. I don't remember whether we've ever done a field test on the Realistic TRC1004. Now I went to the expense and trouble of getting all the Realistic service manuals, and of course it's paying dividends now, and the Realistic service manuals are as good as it gets. You've got the minimum spec. For example, have I got dirt damage, scratchy corner t-shirt? What does it say here? So in this case, this set is 13.2 volts. So we haven't got to faff around worrying about 12 volts, it's 13.2. So that's fine. And at 13.2 volts, it's supposed to do 3.7 watts. And the minimum is 3.4. So this is what this is about. This is why these manuals are so good. And when we come to, what do they say deviation should be? Because this is always a thing. No, I can't see that straightforward. So receive, they've not quoted 10 microvolts, 12 microvolts, they've counted, yeah. So their limit spec is 1 microvolt for 10 dB, which would be pretty lousy, to be frank. And these are made by GRE, or were made by GRE, General Research Electronics in Japan, along with some of their other products, and those shortwave receivers like the DX160 and that. So you won't find this chassis, if I remember rightly, you won't find it in another set. But we have the full service manual and there's everything we can do. Well, tell you what, we'll do what we sometimes have been doing recently, and we'll write down how it works before we start. So I've already lost our lead. It's Saturday today. I'm going to have to do 2 sets when I'm not even supposed to be doing any CBs on a Saturday. But we've put some electronic components on eBay, and I've been so inundated. You know, things like those Maxon mouldings. for the power lead on Maxcom type chassis sets like the Maxcom 4E and Cobra 21 XFM and the Colt 295, etc. So we've got those available, and I put some on eBay, and I've been spending so much time putting them in envelopes and going to the post office that it meant there was no time to do CBs. So I'm going to go and get a piece of paper. Let's see what's on the printer that we don't need. There's usually something. Oh, this is a good one. Manage your tax info online. So we've got that hooked up to our cigarette lighters on our 18 amp power supply, which we use for business radios. So it does have quite a noisy transformer in it. Oh yeah, I haven't apologised for the racket in the background. I've got the air conditioning on in here. This room is air conditioned. The instruments are all at everything's set at 72, between 70 and 72 Fahrenheit, and that's summer and winter. But normally, because we have a one of those Dimplex type oil-filled electric radiators in here, which is on a thermostat, so when it's when it's winter and that, it's silent. But I've got to have the air conditioning on today, not just for my own comfort, but we like these things to be done at a constant temperature. So apologies for the racket, and its compressor's just cut off as it's hit the temperature, but I'm aware of that, and that's how it has to be today. Now what we want is the aerial adapter, and you know what? Where have we got the aerial adapter? Because on these sets it is an RCA phonotype plug. So why haven't we got anything lit up? Okay, I'll pause the video while we find our RCA adapter. Okay, so I've moved the cigarette lighter sockets onto our 2.5 amp power supply, which has got LED metering, which means I can see what current consumption this is doing, and we've got the RCA adapter plug now on there. So we're on channel 19, we'll move that to channel 20. Switch picture in picture on. And with any luck, we'll have transmit. We'll start off on the 3 watt range, and we have 3 watts. We'll call it 2.9. TX 2.9 watts. Deviation. Wallow. 1.8 kilohertz. Frequency. Switch over to the other camera position. 2779115. Dropped slightly, but it's well within spec. And then receive. Well, we can't do the receive because it doesn't have an earphone socket, so we'll have to open it up to do that. But first of all, we'll just make sure we can actually hear something. So we're listening there to 0.3 microvolts. Sounds a bit thin, could be the detector's out, but the sensitivity is certainly there and it's working. So we'll pop the screws out of the back. Screws you don't necessarily want to lose. So the product says 12 volts on the back, negative ground, but it clearly says 13.2 volts in the manual. I think we pull the knobs off this one. Yeah. We try to. Of course, you've got to be aware of the wires going to the electret mic and the loudspeaker. So now we're into that, we can put our crocodile clip lead onto the speaker. And we'll get that cyanide reading. Now, where have I hidden stolen crocodile clip leads off Mr. Chippy's bench? I don't think there's any here at the moment. We'll just have to hold the 3.5mm jack on. Should only need one connection. Yeah. So switch to the cyanide meter. And let's see when we get 12 dB. So RX is 0.6, 0.53 microvolts for 12 dB cyanide. Now they quote 10, so we'll just adjust it to 10. Or 0.48 microvolts for 10 dB cyanide. And just for the laugh, does it do 20? Yeah, it does do 20. Or, see what scale we're on now. 1.25 microvolts for 20 dB cyanide. Okay. So let's just look what that says again. So they want it to be 0.5 microvolts for 10 dB. And we've got 0.48, so that's better. And they want it to be 0.9 for 20. We've got 1.25, but the limit is 1.8. So it's not ideal, but it's fine. And we could let it go, but we're going to optimize it because that's what we're here to do. So you've got all the setup and all the test points. Oh, I love that. Alignment of younger stage. That's a good translation. So we're going to start with transmit. We'll just do the frequency first. And we're going to be adjusting... We're going to find the trimmer capacitor for the synthesizer. And that's going to be hiding. So there's trimmer capacity up there. So we'll just check that we're not messing with the wrong one. I'd hate to have to go through the VCO. So it just says TC there. So we've got the synthesizer chip, which is an LC7137 from Sanyo. We've got the reference crystal, the 10.24 there, and you can see from the print track that that trimmer capacitor, even though it doesn't say which, it clearly goes to there. And we will be able to see that in the circuit diagram. So trimmer capacitor is 20 picofarads and it's on the crystal there. So we can quite safely adjust that. It doesn't even need adjusting, but just for the point of this demonstration, we will switch to camera 2. There we go. Key up. In actual fact, with the lid off, oh, it still just wants to. I was on frequency counter there. It's a strange design, this. I've not seen one like it. Wonder where our yellow tool is. There it is. You know what? You adjust it from the bottom. You don't take this board out. You adjust. It's upside down on the board. That's why it looks funny. You live and learn. So if we take the board out, there's a hole through the board. Well, I've never seen that before. There we go. So I'll press transmit. And there we are, brought it up to where we want it. Wow! I was looking for printed circuit board ID number. It's not the most beautifully washed board I've ever seen. So looking at what's on the transmit stage, well, clearly they are. So let's see what it says in the service manual we're going to be adjusting. So transformer 1 is a second harmonic, which we don't want to be touching, or we'll have to put our spectrum analyzer on. So that one there is the one we're not touching. So it's 8, 9, 10, 11, 4, 7. 8, 9, 10, 11, 4, 7. 8, 9, 10, 11, 4, 7. Right, we're going to transmit. And this, I'll now go on to the 30 watt range. So far they've been at absolute peak already. Well, that's us run out of ideas. So let's see what voltage it does actually do for watts at. 15, we can't have that. I think it says 3.3, doesn't it, was the minimum acceptable. .4, and it says if we can't get, we need to be changing resistor 83 value. So resistor 83 is it that one? That's 61, 84, 85, 83 is that one there. Let's see what they have factory installed there. It selects 83. That's never a quarter watt resistor. .83. Well, what we're going to do, I think we're going to have to take that out. I mean, that's a half watt resistor if ever. And I think we'll put our substitution box in place, and we'll see what we can do within those limits to make the radio do the minimum 3.4 watts. So I'll pause the video while we take that part out. Right, let's see what we've got. I'll tell you what we've got. We've got a flat battery on that meter. Okay, so we won't use that meter. What we got here? Oh, there's another one. There's an impedance meter, but it'll do resistance as well. I could just use the multimeter, but I'm going to use this. No, we don't want capacitor mode. .4 ohms, and it looks to like violet green. I think it's supposed to be 7.5. So going back to this, it's supposed to be 6.8 to 12 ohms. So it's at the lower end already, so we better change it for 6.8. So, I'll just see whether we can faff around with the decade box. Yeah, we'll do this because people like to see experiments. I'll pause the video again. Well, unfortunately that doesn't work out because we can't do it with the long leads. So if we can't do it with long leads, we'll just have to go for a fixed resistor value at a lower end of the range. So hopefully we've got a 1 watt comp card. As I said before, it's a very expensive way of doing it, but it's convenient. These are 2 watts, so that suits me. Oh no, the lowest we've got in this series is 10 ohms. How annoying is that? Oh. Back to the drawing board. So I've made an executive decision. We're going to put this set on one side. Here's a very useful box, which will be very useful to put this away. And we may have these available, these resistors available in another facility. So we'll have to go across there and have a look. We'll put that in there. I was hoping using one of the bigger boxes we'd be able to cram it all in. Where have I put the back? Oh, there it is. Yeah, well, that didn't work, did it? So we've hooked it down at one end. I'll put that on one side. What we'll do is we'll abandon the demonstration on the customer set and we'll try it on mine instead. And if mine needs resistors changing to get to us that magic 3.4 watts, well, we'll put this video out and but the on-the-air test will be with the customer set. So 2 things can happen. We could end up with these things in stock anyway, so we'll have to look at another facility which isn't on site here. And then secondary, I have ordered some, but they'll come Tuesday. So we'll take mine apart instead. Now mine, these screws look a bit more dull. Before I finish taking it apart, let's run through my one. I can hear receive already. See, the service manual says those resistors are 1/4 watt. Well, they're not, they're 2 watt. So it's an error in the service manual. Okay, so we'll start off in the 3 watt range just like we did with the customer's one. Wow. Ours is doing 3.6 watts. So deviation, I've probably been through this anyway in the past. Wallow. No, I haven't. Frequency. Wow, that's off. Still within spec, but it's still off. And receive, or can hear. We can hear 0.3 microvolts. So we'll pop it apart and we'll see what that synod reading is on ours. Yes, they're quite clearly capable of doing more than 2.9 watts, you know, when you compare like for like. And we'll get to the bottom of the customers and we'll soon have that running nicely for him. If I'm struggling to get these knobs off and I've got exceptionally strong fingers, so it needs to pop out of its case. See what we learnt when we experimented on the customer set? Not quite sure why it's stuck at this side. So the first thing we can do is to pop it on frequency. So we'll go into transmit. I'll put the... There we go. Will it go? Yep, that'll do nicely, just slightly higher. So that's one thing done. Again, the board isn't as washed as I would like to see, but that must be how they are. So we'll go through our transmitter now. I can just see the customer watching this. They go, oh yeah, he's going to get the power up. And then we swap over to my set and his doesn't get done at all. But it will get done behind the scenes. We'll probably do a revisited video on his. Okay, so let's get these for optimum. So it's 3.5 watts. This is going to drop with as it warms up, of course, like they all do. So that's it, it's 3.6 watts. It's dropped to 3.5 as it's warmed up, but we're there. Right, deviation. Let's find where that is. Oh, they like you to check low power. Well, will do. Okay, it's slightly high. Oh no, it's not. No. It's 360 milliwatts. It's 10 decibels from where it is on. Yeah, it's fine. Low power's fine, and it doesn't matter anyway. It's not a legal requirement anymore. So deviation, they want you to set to 1.75, but we know it needs to be 2.2 for the UK. So let's get our little oscillator out, and we're going to adjust VR4. So I think we'd better locate VR4 first, so we're not faffing about. VR4. Got the switch. Changes glasses. It is there. Because I'm in on an angle, that doesn't fit very nicely. Let's try it there. Whoa, it's a little bit over the top, that. So just knock it down a fraction. Let's try it there. There we are, spot on. 2.2. So that's done all the transmit things. You've got no meter on this. So let's look at receive. And we haven't noted this one yet. So we'll get the synad meter shoved onto the speaker. We'll switch to the synad meter. So let's get the 12, which is what we want. So I'll put for 10 dB, for 12 dB, and for 20 dB. So for 12 dB, our sample is doing 0.45. Now his was doing 0.48, so there's virtually nothing in that. So let's look at 10. Ours is doing 0.37. Oh no, it is DEFA. Look, it was 0.53 for 12. I didn't put them in sequence. And then for 20, ours is doing 0.95 microvolts. So we'll just start by doing the detector, which I think is going to be that. I can't see quickly that it says do the detector. Has it not got one? It's possible. Well, T6 looks like the detector to me. And it bundles in T6 with the other alignment. Okay. Well, we're going to do T6 first. So T6, no, that's T5, you see, it goes to show. T6 is that one. And then they want us to do what? 2, 3, 4, 5. 2, 3, 4, 5, that's it. Okay, so with 100 microvolts, we'll put the oscilloscope on, we'll turn the bench light off, we'll switch over to the oscilloscope, and I'll hold this on the speaker, not knowing where the crocodile clips are this week. We'll just pop the volume up so we've got a decent size trace, and we'll just see whether we've got maximum on there. We've actually got a bit more out of that. So now we'll go over to the synad meter. For those of you who like my shoestring budget videos, we've got another Chinese cheap signal generator coming. It is now in this country. It's been on order about 6 weeks. And it's like the one I'm using for as a marker oscillator, but goes up to 30 megs. Okay, so that's in a useful position for us to do the front end. Tell you what, we've got an improvement with that one. I'll put a bit more signal on because that one there is going to be an IF one. Oops. Put a bit more signal on still. You know what I've gone and done? I've gone and adjusted the transmit, don't ever adjust it one. I have to put the spectrum analyzer on to put that back. What a wally. Okay, let's look at the new readings. So there's our 10 dB, and it's now 0.34 microvolts. Twelve 0.44 microvolts, and 20 still 0.95. So we've got a little bit of something. Let's hope that the customer's one will come to that level later on when we return to it. I'll put the spectrum analyzer on. We're just going to have to check out where we are with this. By the way, folks, there is a 10 dB attenuator on this spectrum analyzer. So we'll switch to that. Hopefully it'll come on. And we'll adjust this for minimum. Oh yeah, I think that's not the one. Interesting. We haven't got anything on double. So we'll go to 27 megs. There's our 27 meg signal. No, we've got nothing. We haven't got anything. It's fine. And we're still doing the same power, so that's fine as well. So that leaves the squelch, which they call receiving range. So we'll put that to full, and we'll advance the signal generator to 100 microvolts, which is an S9 equivalent signal. That's coming. It's coming at 3 microvolts. Now it might not work like a normal set because it's an emergency set, but we'll see whether we can adjust it something like. So I just need to find where the squelch control is. VR2 is receiving range, adjust VR3. So there's VR4. There's VR3. Had to be somewhere in the receiver. So it's that one. I've turned that to full. Let's see where that takes us. 10, 30, 100. So we want to drop that till it comes in. It's going to be one of those, is it? It's not going to set up how I want it to be. Now, 10's the best we can get, so but we have to appreciate it's an emergency set. This was 3 microvolts as it came in. For it to open at all sensibly, then that's how it's set. So not the best squelch. You'd say it was wheat and Walkthrough, but we're not likely to be using this as a base station. It's set to do the on-the-air test. So we'll test it at the important end. So we'll switch the signal generator to 0.3 microvolts and put it to standby there. Turn the squelch down, set it to threshold, switch the signal generator back on. We're straight in. So squelch is coming in at 0.2 of a microvolt. It's leaving us at 0.11 microvolt. So, you know, it's really sensitive. You're going to hear lots of people. It's an emergency, say, it isn't a base station. So I'll start putting this back together. Okay, so now I've put mine back together and we'll look at whether we can receive anything. Well, Nana, Roger. So Aaron's on the air, whoever he is. We'll put this ready for our test later on channel 31. I'll tell you what we will do while we've got this kind of in mind. We'll bring back the customers and I'll do the receive side of his. And let's see whether we can get it anywhere near as good as ours. Now his was already better than the manual said, but ours is exceptionally good. And then on this one, all we're going to have to do to finish it is to finish that transmitter off, which will be a matter of changing that resistor. We'll start with the detector. We'll go over to the oscilloscope, turn the bench light off. Turn the volume up a fraction. See whether he's got optimum. Yeah, it was already at optimum. No adjustment necessary. So now we'll drop it to about there. See whether we can improve the receiver and not upset his No improvement on that one. Just pop the signal up for that IF one. We'll take a new reading for the customer set. So we'll start with the 12, which is what we want. And we now have for 12, we have improved it. We've now got 0.45. You see, you just can't hear these with your ear. That's why we use the instruments. 10. It's about there. 0.39. And 20. Is now 0.1, which is exact. Sorry, it's now 1. Which is exactly what the manual said it wanted to be as optimum. So we've beaten the manual and we've got him 1. So when we look at these figures now between his and mine, his 10 dB is 0.39, mine's 0.34. His 12 dB is 0.45, mine's 0.44. There's nothing in it. And his 20 dB is 1 microvolt, and ours is 0.95. So there was quite a gap. Now there's hardly any gap. So that's great. And we'll do the receive. We'll do the squelch on his. Let's remember what we do. We'll turn the squelch to full. Bring that up a long way. Where's his squelch control? It's hiding. So we'll set that so that it comes in. There we go. And maximum squelch is about 10 microvolts, which is much of a muchness like mine is. Let's go down to the other end. So we'll now turn the signal generator to standby, which I'll just go over to the attenuator controls, I'll turn it to standby, put it to 0.3 of a microvolt, turn the squelch down on the radio, set it to threshold, and let's see where it comes in. Just like mine, it's straight in. So it's coming. The squelch comes in at 0.22 of microvolt, and it leaves us at an incredible 0.09. So very good. That's a vast improvement. So I'll just need to finish that transmitter off, but that'll be either on a revisited video or just behind the scenes. Just put that back in the box. So there's nothing to think about. That's back to standby. Right, well, there you go. Thank you for watching. And I'm going to just check the continuity of our aerial, because you just never know, do you? So thank you for watching the Realistic TRC1004, where we got 1 3/4 sets done, and there'll be an on-the-air test later, but we'll be doing the on-the-air test with the customer set and not my set. I'll announce how many watts we got out of it on that video.